Hello, my dear friends. I welcome you all in my 8th video of Physical Sciences for class 9th. So, in this video, what we will be doing is studying about a form of energy. But before we can start with that form of energy, I would like to quickly recapitulate about what we have studied in our previous class. You can see that in our previous video. So in our previous video, we saw about a form of energy known as the kinetic energy. Kinetic energy is the energy possessed by a body by the virtue of its motion, and its formula is half mv squared. Right, students? So today we are going to learn about another form of energy. So I will be showing you this picture. So please look at this picture and tell me what you can see from this picture. Yes, students? Right. So from this picture, you can see that a brick is there on the roof of the house. Right. So now, if suppose I place you here and this brick falls from here, you will get hurt or not? Yes, you will definitely get hurt, students, because this brick is also having some form of energy which it will transfer it to you, isn't it, students? When this energy will be transferred to you, you will feel hurt. Now see this boy. This boy is just letting go of this ball, and this ball is getting kinetic energy to move. So this ball is also having some energy, isn't it, students? Right. Now just quickly go to your drawing room or your where your mom keeps the rubber band. So go there and just bring a piece of rubber band. Okay, students? Right. Just bring a rubber band. Okay. Right. I'm giving you 2 seconds to do this. Okay. Now you see, students, I have brought a piece of uh, thick rubber. It is a very long piece of rubber. So if I stretch it, so it is getting stretched, isn't it? But if I let go, let loose of it, it is getting relaxed, right? So why it is happening, students? Yes, why it is happening? Right, because there is some form of energy that is trying to resist the change it is having. Okay, students? Right. So today we will be going to learn about that form of energy, and that form of energy is called as what? That form of energy is known as potential energy. That form of energy is called as potential energy. So now let's start our discussion for potential energy. So let's see these pictures. Okay, students, this is a roller coaster. Okay, so this roller coaster, when it is reaching at a very high point, then it is also posing potential energy, and then it will fall freely, right? It will not be using any energy, it will just use the potential energy it is having to move itself, right? So in the case of dam, in the case of apple on a tree, a bow and an arrow, a slingshot, all these have potential energy, right? So in these situations, the energy is stored due to the work done on the object, right? So this roller coaster, when it was here some time ago, isn't it? So work is being done to make it go till here, isn't it, students? So work has been done on this uh, roller coaster or any object, right? So in dam also we can see that the water is being stored here, has been put there, isn't it, students? Right. So the potential energy possessed by the object, right? So this is the definition. The potential energy possessed by the object is the energy present in it by the virtue of its position or configuration. Understood, students? The potential energy possessed by the object is the energy present in it by the virtue of its position or configuration. Okay, students? Right. So, students, we did this experiment with the rubber band. So when we stressed it, what happened? This rubber band like stretched, isn't it? But as soon as we left it, it got back to its original shape. So the band will tend to regain its original length, isn't it, students? Right. So the band had acquired energy in its stretched position, right? When we stretch the band, it had acquired energy, and we let go, it removed that energy and got back into its original shape. Okay, students? Right. So now there is a quiz for you, and the quiz is that you need to define potential energy. Okay, students, you need to define potential energy. So, what is the potential energy, students? Potential energy is the energy possessed by the object by the virtue of its position, understood, or configuration, understood. So, potential energy is the energy possessed by a body due to its position or configuration. Right. So, students, now just think about the second question. The second question states that why an object falling from a height hurt people? Do you got this question, students? Why an object falling from a height hurt people? So students, the answer is that when an object is at any height, it is having potential energy. Understood, students? This object is having potential energy, and when it is falling on someone, it is transferring that potential energy to that person. As a result, what is happening? That person is getting hurt. Okay, students? So now let's go to our second module or second part. So students, here is a picture. So what you can see from this picture, students? Yes, there are different planets, right? So every planet is having its own gravity, isn't it? Even moon is having its gravity. We saw in our previous class that moon is having the gravity which is equal to 1 by 6 times that of the earth. Means 1/6 of the gravity of the earth is possessed by the moon, right? So students, here is my phone. Okay, students, I want to lift it. So how much force will be required? Yes, the force that will be required will be equal to its weight, isn't it? So it will be what? The force will be m into g, because I am doing the work against the gravity, or I am raising it up, so it will be mg. Okay, students? So now what will be the work done, students? We know that the work done in this case will be mgh, right, students? So the gravitation potential energy when an object increases its energy when it is raised to the height. Understood, student? See this box. This box, when it is raised and put on this table, its energy increased. Its energy increased. Why? Because its height increased, right? So some work has been done on this box to lift it from here and place it here, right? So the object increase its energy when it is raised in height. Understood? Why this is done? Why this is being done? Because the work is done on it against the gravity while it is being raised. Understood? So the gravity is pulling it down. So someone has to lift this and place it on the table. Right, students? Okay. So, students, so the energy present in such an object is the gravitational potential energy, right, students? So now let's derive the equation for the gravitational potential energy. Okay, so let's assume that this box is having the mass m. Okay, this box is having mass m, and this is height. This height is equal to h, right? So acceleration due to gravity, we all know that it is equal to g, right? So to do this work, what we require force. Okay, so we know that from the Newton's second law of motion, we know force equals to mass into acceleration. Yes, so students, force is mass times acceleration. So in this case, force will be equal to what? It will be equal to mass times acceleration due to gravity, because force is done against the gravity, so it will be mg, right, students? So we know that to calculate the gravitational potential energy, we have to calculate the work done, because energy is nothing but the ability to do work. Okay, so the formula for work done is what? The formula for work done is F into S, or force into displacement, right? So the gravitational potential energy we can write as force into displacement. What is the displacement here, students? It is the height. So we can write F into H. Right, students? Yes. So F into H. So putting the value of F, what we will get? We will get the value of gravitational potential energy as what? We will get it as mgh. So the value of gravitational potential energy will be mgh. Understood, students? Right. So now let's proceed ahead. So students, here is one thing that I want you to think. Okay, students? So there are three objects, right? So see this object, and see this object, right? Just make the observations. Object A, object B, and object C, right? So tell me which of these objects will have the most energy. Understood, students? Yes. So let's think about it. So see here, height is h1 suppose, and this height is h2. So, okay, so it is visible from the picture only that h2 is more than the h1, right? So we see that object A and object C are of similar dimensions, and assuming that all the three balls are made from the same material, we can say that object of mass A, the mass of object A, right? Mass of object A equals to the mass of object C is greater than the mass of object B, right? So students, in the case of object A, we see that the mass is more but the height is less. In the case of object B, we see that the height is there, height is more, but the mass of the object B is less. But in the case of object C, we see that what is happening? Its mass is also more and height is also more. So object C will be having the most potential energy. Right, students? Okay, students. Now look at this picture, right? So, students, from this picture, we can see that the height component or h component that we take, it is between the directly between point A and point B, not with any other path. It is in the direct straight line or the shortest path possible. Understood, students? Right. The height or the h component will depend only upon the initial and the final positions. Understood? So shall we move ahead? Okay, right. So students, here is a numerical that we need to solve. So we need to find the energy possessed by an object of mass 10 kg when it is at a height of 6 meters above the ground. Okay, students, right? So, right, let's try to find out what is the potential energy. For the potential energy, what is the formula? Formula is mgh. So what is the value of m? It is 10 kgs, right? G is what? G is 9.8 meter per second squared, and h is what? H is 6 meters, right? So this will be equal to what? This will be equals to 98 times 6. This will be equal to right. It will be 588 joules of energy it will possess. Okay, students, it will possess 588 joules of energy. Understood? Yes. So shall we proceed ahead? Tell me, dear students. Right. So we will proceed ahead. So, but before proceeding ahead, so let's think how we solve this question. We solve this question by doing what? By multiplying mass into acceleration due to gravity into height. Why? Because this is the formula for potential energy. Right. So now let's move ahead. So students, what you can see from this picture? Yes. Okay, we can see rubber band or elastic bands, and we can also see a bow and an arrow, right? So students, these things possess what we call elastic potential energy. Like the experiment that we did, like activity we did in this beginning of the class, what we saw that whenever we stretch a piece of rubber band and we release it, it comes back to its original shape, right? So when an object is deformed, the molecule that forms the material move away from their equilibrium position. Okay, students? What happens when the object is deformed? Suppose that this rubber band is being deformed, the molecules that makes up this material is getting away from their equilibrium position. Okay, so if the material is elastic, then what will happen? Those molecules will try to regain its original configuration, right? It will try to get into those equilibrium positions, right? So therefore, when an elastic material is deformed, we say that the material has elastic potential energy. Okay, when an elastic material is deformed, we say that material has elastic potential energy. Understood, students? Right. So shall we move ahead? Okay. So just see here, it is a bow and an arrow. You can see this bow firing the arrow, isn't it? So just see what is happening when the arrow is being fired, right? You can see that this thread is getting pulled back, right? So the potential energy is stored in the bow due to the shape of the bow, isn't it? So you can see when it is pulled back, the shape of the bow is changing, right? And this changing of the shape provides it with the potential energy, and when you release it, that potential energy gets converted into what? Gets converted into kinetic energy that is used in throwing of the arrow. Understood, students, how the bow fires? Yes. So now let's proceed ahead. So students, there is a quiz for you. So the first question is, what is elastic potential energy? The first question is, what is elastic potential energy? Right. The elastic potential energy, students, is the energy possessed by any body, right? Possessed by something due to its position, right? Its configuration. Understood, students? Yes? Right. What are some examples of elastic potential energy, students? So some examples of the elastic potential energy is rubber bands, bow and arrow, isn't it? These are some examples of the elastic potential energy. So in the case of rubber band, what is happening here, that when we try to stretch the rubber band is getting stretched, no doubt. But then again, what is happening? The rubber band, as soon as we remove the force that is keeping the rubber band stretched, it gets back into its original shape, right? In the case of bow and arrow, we pull the bow so that we can release the arrow, isn't it? When we pull the bow, what happens? The energy is released in the form of kinetic energy, because the potential energy that was stored in the bow is getting converted into the kinetic energy. Understood, students? Okay. So now let's proceed ahead. So today, what we have studied? Today we have studied about the potential energy. So now let's quickly answer a few questions. Understood, students? So first of all, let's define what is the potential energy, right? So we can define potential energy as the energy possessed by anybody by the virtue of its position or configuration. Understood? Energy possessed by anybody by the virtue of its position or configuration. What we call it? We call it as potential energy. So what is the SI unit of potential energy, students? Right. So the SI unit of the potential energy is joules, right? So what is gravitation potential energy? So the gravitation potential energy is the energy possessed by any object by the virtue of its position, right? By the virtue of its position, right? So now what is elastic potential energy? Elastic potential energy is the energy possessed by any object by the virtue of its configuration, right? So energy possessed by the virtue of its position is called as what? Potential energy. Which type of potential energy? Gravitation potential energy. And the energy possessed by any object by the virtue of its configuration is called as the elastic potential energy. Right, students? So now, what are the two examples of elastic potential energy? Yes, students. So first one can be the rubber band, and the second one can be what? The second one can be bow and arrow. Understood, students? Right. Now let's come to the homework section. Here is a numerical. So an object of mass 12 kg is at certain height above the ground. If the potential energy of the object is 480 joule, then you need to find the height at which the object is concerning the ground. Okay, students? Right. So given G is 10 meter per second squared. So this is your homework. So that's all for today, students. Have a nice day. Thank you.